Let's now recap what you have learned about metallic bond at O-level. Metallic bond is formed when metal atoms delocalize their valence electrons, consequently forming cations. So the delocalized electron acts as the glue to actually hold the cations together as they electrostatically attract them, since both are oppositely in charge. Hence, the strong electrostatic attraction forces between the cation and the delocalized electrons gives rise to its physical properties. For example, high melting point and boiling point. The free mobile electrons allow it to be a good electrical and heat conductor. Metal is malleable and ductile, since closely packed cations could actually slide across each other when a force is applied, as the mobile free-moving electrons continue to hold the plane of cations when they slide. Finally, metal is insoluble in both polar and non-polar solvent. At the A level, the strength of the metallic bond depends on two factors. The first factor is the number of delocalized electrons. The greater the number of delocalized electrons, the stronger the melting point. The second factor is the charge density of the cation. So when a metal atom loses more electrons, the charge density will be higher, since the charge will become higher and the size of the cation becomes smaller. For example, if you were to compare the melting point across the period from sodium to magnesium to aluminium, you can see the boiling point and the melting point increasing. The reason is because aluminium has a total of 3 valence electrons, so it could delocalize more electrons relative to sodium, which only has 1 valence electron. Consequently, when aluminium delocalizes 3 electrons, it will form the cation Al3+, where its charge density will be significantly higher than that of sodium, which actually will form the cation Na+ after delocalizing 1 electron. Finally, as a general trend, you will find that metallic bond is generally weaker than ionic bond. The reason is because in the formation of metallic bond, electrons are mobile, and therefore the metallic bond form, or the electrostatic attraction force between the electron and the cation, are transient. While in the case of ionic bond, the oppositely charged cation and anions are all held in fixed position. These electrostatic forces are fixed and are not transient.